Number 5 on 3-5 says, you have 17 coins in pennies, nickels, and dimes in your pocket. The value of the coins is 47 cents. There are 4 times the number of pennies as nickels. How many of each type of coin do you have? So we want to start with first things first. We first see that we've got 17 coins in pennies, nickels, and dimes. So let's start that. 17 coins is equal. Let's let P equal the number of pennies, plus N equal the number of nickels, and plus D equal the number of dimes. So we have that 17 is equal to pennies, the number of pennies, plus the number of nickels, plus the number of dimes. That's 17 coins. So now we're through there. It says the value of the coins is 47 cents. So we know 0.47 is equal to what? The number of pennies and their value. So they're worth a penny, 1 cent each. So 0.01 times the number of pennies. And nickels are 5 cents. So 0.05 times the number of nickels, and a dime is 10 cents. So 0.10 times the number of dimes. So there we go. There's our second equation. So we're through with that. The last thing we're going to work with, it says there are 4 times the number of pennies as nickels. So it means our number of pennies, we have 4 times the number of pennies. So pennies is equal to 4 times the number of nickels. So there's our 3 equations for our system for this problem. So it looks like because of this one equation, here, the pennies equals 4 times the number of nickels. We can use this easily in substitution on problems 1 and 2. And that's our third problem. So let's first do that. Let's substitute. Man, I totally lost my problem. There it is. Sorry about that. Okay, so the first thing we're going to do is substitute 4n into equation 1 for p. So we're going to start with 17 equals p. I'm just copying the first equation, plus n plus d. And we know that the pennies is equal to 4n, so we're going to substitute that. 17 equals 4n plus n plus d. Now let's solve that. 4n plus n is 5n plus d. So we have our fourth equation is equal to 17 equals 5n plus d. So now let's do this again in equation 2. But equation 2 has a lot of decimals in it. So let's first clear our decimals. So for equation 2, we have 0.47 equals 0.01p plus 0.05n plus 0.10d. And we want to clear all these decimals, so I'm going to multiply everything, because it's 2 decimal places, I'm going to multiply it by 100. So that clears this up. So this becomes Going back 2 decimal places, 47 equals 2 decimal places, 1p plus 2 decimal places, 5n plus 2 decimal places, 10d. Now I've cleared all those decimals for equation 2. Okay, so now I'm going to substitute my 4n for p into equation 2. So we're going to have 47 equals 1 times p, which is 4n, plus 5n plus 10d. Now, 1 times 4n is just 4n, and 4n plus 5n is 9n. Carry down plus 10d, and then on this side it's 47 equals. Okay, now we have equation 5. So now let's combine equation 4 and 5 and eliminate one more variable. So equation 4 was 17 equals 5n plus d. And equation 5 was 47 equals 9n plus 10d. Well, we have to eliminate another variable. I'm going to choose to eliminate d. So in order to do that, I'm going to have to multiply my top line by a negative 10. So when we do that, we get, and I'll do it down here, negative 10 times 17 is negative 170 equals negative 50n minus 10d. So there's my equation rewritten, and I'm just going to copy this one back down here. 47 equals 9n plus 10d. Now, when I add these two, I'm going to get negative 41n equals, and when we do this one, I'm going to get a negative 123. So when you divide each side by negative 41, I'm going to get that n is equal to 3. So we know now part of my solution, I have 3 nickels. So there's the first thing they ask for. How many of each type of coin do you have? Well, I'm going to have nickels. We have 3 nickels. Now we know our pennies equals right here 4n, and nickels is 3, so 4 times 3 is 12. So we have 12 pennies. And now that we've got nickels and pennies, we can plug that back in and get our dimes. Okay, so let's use our first equation. 17 equals p plus n plus d. And we know the pennies is 12 and our nickels is 3. And let's solve this for d. So that's going to be a 15. And then subtract 15 from each side, and you get a 2 is equal to d. So we have 2 dimes. And that's our answer. Okay, number 10 states, for a party, you are cooking a large amount of stew that has meat, potatoes, and carrots. So right off the bat, I'm going to stop and I'm going to say, let's let X represent meat, Y represent potatoes, and Z represent carrots. So it says the meat costs $6 per pound, the potatoes cost $3 per pound, and the carrots cost $1 per pound. You spend $48.50 on 13.5 pounds of food, and you buy twice as many carrots as potatoes. So A says, write a system of 3 equations that represent how much food you bought. So let's start there. So we know let's talk about the quantity. We have pounds of meat. So how many pounds of food did we buy? 13 and a half. So 13 and a half pounds of food is equal to the pound. Let's let X represent the pounds of meat. Let's let Y represent the pounds of potatoes. And Z represent the pounds of carrots. So that's taken care of. Now, again, the meat is X, the potatoes are Y, and the carrots are Z. So now let's work. We've done this and this. Let's work on the next thing. It says we spent $48.50. So now let's go to the money. $48.50 is equal to $6 per pound of meat. So $6 times the pounds of meat. Plus, so that one's done. The potatoes are $3 per pound, so $3 times the number of pounds of potatoes. And the carrots are $1, so $1 times the number of pounds of carrots. So there's our second equation. So now that's gotten us through all three of these lines. The last thing it says is you buy twice as many carrots as potatoes. So the number of carrots, which we said, let's let Z represent the pounds of carrots, is equal to double the potatoes. And our potatoes is Y. So there is our system of three equations. So that's the answer for A. So now that we have our equation, we have to go to B. How much of each ingredient did you buy? So we can see that because of our, excuse me, let's try that one more time. Our Z equal to Y, we're going to substitute 2Y in for Z into both of these equations and get our equations 4 and 5. So saying this is equation 1, this is equation 2, and this is equation 3. Now we're going to substitute equation 3 into equations 1 and 2 and get 4 and 5 respectively. So let's begin that. So for equation 1, we're going to have 1350 equals X plus Y plus Z, and we said that Z is equal to 2Y. So we're going to put in 2Y. And solving for that, we have 1350 equals X plus 2Y plus Y is 3Y. So now we've got equation 4 right here. Okay, now we're going to substitute equation 3 into our equation 2 to get our equation 5. So now we're going to take 4850 equals 6x plus 3y plus 1 times z, which is 2y. And 1 times 2y is just 2y. Okay, so now we're going to combine like terms. 3y plus 2y is 5y. So our equation number 5 becomes 4850 equals 6x plus 5y. So now we've got one variable eliminated, and now we're down to 2. So we have equation 4, 1350 equals x plus 3y, and equation 5, 4850 equals 6x plus 5y. Now we're going to combine those two and eliminate another variable. So let's do that. So now I'm going to take 1350 equals x plus 3y, and 4850 equals 6x plus 5y. Now I want to look at these x's and my y's and see what can I eliminate. Well, if I add, I can't eliminate anything. So I have to alter one of our equations. And this was equation 4, and this was equation 5. I'm going to alter equation 4 to create a negative 6x. So when I add them, my x's will go to 0. So that means I have to multiply everything by negative 6. So when I do this, I'm going to get, for equation 4, now I'm just multiplying the negative 6 times 1350. So I'm going to get negative 4850 equals negative 6x minus 18y. Oh, excuse me, I made a mistake here. I copied the next equation over. Negative 6 times 1350 right here. That equals negative 81. I'm sorry about that. And the rest of it is correct. Negative 6x minus 18y. So that's our equation 4 rewritten. And now a straight copy of equation 5. So now this is going to be 4850 equals 6x plus 5y. Now, when I add equations 4 and 5, my x's are going to eliminate. And then I'm going to have minus 13y here. And 81 minus 4850 is actually negative 3250. Now when I divide each side by a negative 13, my signs cancel out, and I get y equals 2.5. Now what did y represent? Y represented our potatoes. So let's start an answer box up here. We're going to have meat, which was our x value, potatoes, which was our y, and carrots, which is our z. Okay? So we just found out that y is equal to 2.5. So we have 2.5 pounds of potatoes. Now we can quickly go and get our carrots, right? Because that's just our z equals 2 times y. Well, if y is 2.5, then 2 times 2.5 is equal to 5. So our carrots, we have 5 pounds of our carrots. See how easy that was to get? Now that we have our potatoes and carrots, all we need is our meat. So let's take our easiest equation right here, our first one, and plug in y and z and solve for x. So let's do that here. So we have 1350 equals x, which is our unknown, our carrots, plus y, which is 2.5, plus z, which is 5. Well, 2.5 and 5 is just 7.5. Right? So now we have 1350 equals x plus 7.5. Now when I subtract 7.5 from each side, I'm going to get 6. So there's my last variable. I have 6 pounds of meat, 2.5 pounds of potatoes, and 5 pounds of carrots. Oops. all right? And that is our answer. Thank you for watching.